you are involved in designing or installing domestic hot water systems for commercial properties, you have most certainly run into the following problem. You would love to use a larger thermal storage tank. Not only is it needed to meet the hot water demand of the building, but it also allows you to tap into several other advantages. It helps your existing source of energy run more efficiently. It can save you money by avoiding peak rate cycles and lower demand charges for monthly maximum power usage. It also increases the margin of error if the system is not operating perfectly. But there often is one big, or should we say, small, problem. The door to the mechanical room is too small to fit a larger tank through it. As a resourceful professional, you have always found a solution, combining multiple smaller tanks into an array. That, however, has been driving cost and system complexity up. You always knew it was not ideal, but the best option under the circumstances. That is, until now. Introducing the thermal tank. Available in sizes from 350 to 700 gallons on a 60-inch diameter, with larger versions coming soon, the thermal tank is one of a kind. It is modular in its design, which allows for easy transport to the site and assembly on site, even in tight mechanical rooms or other difficult-to-access spaces. It is made of lightweight materials. No individual component of the tank weighs more than 15 pounds. Anyone can carry them, and each one easily fits through even the smallest door. The tank is among the highest-performing tanks in the industry, with R values ranging from R equals 18 to R equals 22, depending on size. Even our smallest commercial tank, the 350-gallon tank, loses less than 3.8 degrees Fahrenheit over 24 hours in free convection. The thermal tank also operates differently. Water is used as a thermal battery fluid, filled into the tank once and only moving within the tank and the connection to the heat source, such as a heat pump. We recommend water as storage medium for ease of operation, but other mixes are also possible. The optimal tank temperature is between 110 to 140 degrees Fahrenheit, but higher temps up to 180 degrees Fahrenheit can also be supported. The usage water on the load side is heated via a heat exchanger and never mixes with the tank water. The tank is unpressurized and can hold 55 kilowatt-hours in the 350-gallon version. The thermal tank is made entirely of non-corrosive materials. The EPP walls, TPO surrounds, and PVC liners are eco-friendly in their production, with a more favorable ecological footprint than steel tanks. No bonded materials are used, and all component materials are 100% recyclable. The various design factors result in significantly lower cost to install, lower cost for maintenance, and substantial operating savings as described above. Should the tank ever need to be moved or disposed of, then it can be disassembled just as easily as it was assembled. In more advanced use cases, the thermal tank can also support heating and cooling applications. We even had clients use a tank farm in place of a large cistern. Lack of large thermal tank options was yesterday. The thermal tank is the answer for your next larger-scale DHW system. Check out more details on thermalenergyhq.com or contact us at info@thermalenergyhq.com.